Hi, everybody. So today I'm going to be showing how to find the value at risk for this portfolio of stocks that I have here, specifically for their min-variance portfolio. So I've got Apple, Amazon, Goldman Sachs, JP Morgan, Microsoft, Nvidia, SPY, Tesla, and Walmart. And what I'm going to do first is come here and rename this sheet to returns. So I'm going to copy this and then go to the next sheet and do Control Shift V, and then let me try something. I'm gonna do all of these divided by um all of these all the way to the last element minus 1.0. Okay, so I managed to calculate the rate of returns for all these stocks. The next step for me is to calculate um the mean. Yeah. Well, okay. So I have returns in here. I'm gonna come here and do rename this to min variance. So here I'm going to have portfolio weights, and it's going to be, let me come back here, copy all of these. Wait, copy, paste, and then I'm going to make all of these have a border. I'm going to color them yellow to make them inputs. I'm going to center these. So these are portfolio weights. Um, the next step is going to be to compute the covariance matrix. And before I do that, I will come here and do um, minimize risk. So this will hold the risk parameter. We also come here and increase this. Okay, let me change this back to 8.43. So this is going to have a border around it as well, but this time I'm going to make this color green. So, okay, so I need to compute the covariance matrix of these, so I'm going to come here, do Control C, Control V, and then this is 3, 6, 9. I'm going to do transpose. Okay, so in order for me to do the covariance matrix, I have to come to returns and I have to calculate their means. So it's going to be, so I'll do equals average and then fill it all the way. So these are the average of the stocks. To make this easier, I'm going to call this X. I'm going to call this mu. So it'll be M mult of transpose X minus mu to X minus mu. Okay, so I got the covariance matrix. So what I'm going to do to that is add a heat map. Yeah, add a heat map. And then in order to get the minimized risk, let me go ahead and just put in some random values. So 1, 1, 1, 1, 1, 1. Um, Let me center these. So this will be M mult of weights by M mult of the covariance matrix times transpose. I know these are opposite dimensions because it's Excel. It's gonna be our minimized risk. So I'm gonna, it's not actually 200. Well, maybe I should make this white. Yeah, I'll change this Yeah, that's much better. So right now our minimized risk is 253%, but that's not the actual. So I have the constraints now. So that's going to be constraints. So it's going to be constraint A is going to be 1, 1, 1, 1, 1, 1, 1, 1. So I will label this as, wait, let me actually make this wider to 14. So constraint A is going to make sure that all of these weights add up to 1. So it's going to be sum product, the sum product function. So it's going to be weights multiplied by this first row. Actually, I can go ahead and freeze these cells. So this is 9. So this is going to be, let me just fill all these to the right. And then this is going to be left-hand side and then sign. And this is going to be equals. No, yeah, equals. Let me put that in the middle. Let me actually minus that, make all these in the middle. Okay, so this is gonna be right hand side and it's going to be 1. So the weight should add up to 1. So now the next step is to make sure these are all non-zero or non-negative. I think I could do that in the solver. So what I'm gonna do is let's see. Um call this, wait. Actually, yeah, let me just look in solver. So it's gonna be data solver. We're trying to minimize M6 by changing the variables of the weights. So we're going to add a constraint. So left-hand side equals right-hand side and make unconstrained variables non-negative. Yeah, let's try this just to make sure that none of the weights are negative because I don't want to have to short any of these. And we're going to use GRG nonlinear as the optimizer because I think this is, yeah, I'm pretty sure this is a nonlinear optimization. So I hit solve. Okay, so I got some values. So it's saying 3% in Apple, 7% in JP Morgan, 59% in SPY, which is not surprising. This is the min variance portfolio. 0 in Tesla, and 29%, 0.5% in Walmart. Um, what I'm gonna do is I want to, yeah, I'm gonna have to compute the portfolio beta as well. Okay, so we got 1% as our minimized risk. Um, is that, oh right, it's in variance form. So I'll do min risk. So this is gonna be the square root to get the volatility. So yeah, 10.34%. That's our minimized risk. Okay, so what I want to do now is come over here and I'll call this risk. So we have the weights now. Let me start off with the portfolio beta, and this is going to be, wait, let me actually do stock beta. So ahead and copy these. So Control C, Control V. So it'll be equal to, um, so start with, oh wait, let me go back to risk. So it'll be equal to covariance dot sample size of returns 1, and I'm going to freeze this one divided by the variance, no, var s of the spider ETF. So Okay, so now we could yep, all the betas are printed. So let me go ahead and format these to wait, no, I don't want to do that. Let me do it to 3. Okay, so yeah, this is good. Um, let me go ahead and bold this. So stock beta. Okay, so this is going to be portfolio beta is going to equal so the min variance, so the sum product of the min variance weights multiplied by the betas. Okay, so our portfolio beta, I will add some color to it, text fill. So 0.76. So yeah, this is not too much of a risky portfolio. I'll actually paste this here. Okay, so now we could do stock value at risk. So in order to do this, I need to I'll call this, wait, I should do yeah, it's gonna be the whole thing. Okay, so it's gonna be M mult of, oh wait, I called it X over here. So it's gonna be X by um min variance transpose. Okay, so I have the portfolio returns. So what I'm gonna do is come here to data, or no, insert table. Does it have headers? Nope. Okay. Actually, maybe it's better if I do it this way. I'll call this returns, and I'll call this N, no, T. So what is this spill? Oh, right. I think I'd be better off doing, instead of the matrix algebra part, I think I should just do equals, so sum product of the min variance weights and, well, let me go ahead and freeze the min variance rates, but I'm gonna do it to returns. So yeah, I'm gonna do it like this. Okay, so this equals 1. So now I'm gonna fill this down equals plus 1, and then just drag this down. I'm not the best at Excel, but I can make it work. So I believe it was 235 days. Okay, so yeah, I could get rid of these. Oh wait, there's still more. Okay, so now we'll actually let me come here and do Alt N T, and does it? Uh, shit. Um, Alt N T. My table has headers. Okay, so then sort from smallest to largest. So let me go ahead and make these into percents. Okay, so this is T. I don't like this color. I mean, I know it doesn't matter much in this, but like, yeah, this is better. So now for the value at risk, I'm gonna do, so the first thing I'm gonna do is count the number of returns. So there's 235 returns. The alpha is going to be 5%, and the I'll call this I, which is going to be the integer of the total number of returns times alpha, and then the value at risk is going to equal VLOOKUP of this value to this table array, and it's looking in the second column. So 11, yep, we got 1.14%. Okay, so I'm gonna come here, merge and center this, so I'll call this alpha. So it'll be, no, I don't want to do it like that. I'm gonna come here and get the value at risk, and then I'm gonna do 1%, 5%, and 10%. So this is going to be, let me just get rid of that right now. Wait, a what if data table. So the column input cell is going to be the value at risk. Um, oh no, I did it backwards. What if analysis data table. The row input cell is going to be the value at, oh no, alpha. Okay, I got myself tricked right now. Column input cell is going to be the alpha. Okay, so we could see that we have, of course, the value at risk goes down as you pick the higher alpha, which means it won't be as accurate. So it's going to be L. Okay, that's weird. Okay, so let me just do. Okay, so I'll call this value at risk. So yeah, now we got the portfolio value at risk. So yeah, let me actually do this like this. So this is going to be bold, bold. Um, so now let's see what else we could do with this. We can calculate portfolio mean and volatility. So it's going to be mean volatility. So this is going to be average return. And then let me go ahead and do that. And then it's going to be standard deviation. And then I'm going to just format paint this. Okay, so actually, let me do this. My bad. Okay, so now bold this, bold this. Um, okay, so we have the stock beta, the value at risk, portfolio mean and volatility. I think okay, so we got the covariance matrix here. Yeah, let me just go ahead and format these. I don't want to close the video without it being formatted in case you want to play around with the Excel file. But yeah, I'm gonna bold all that, bold this. Um, so returns are good, and here's our stock data. So yeah, I think they're okay. So I got the portfolio beta, I got the value at risk of the portfolio. Oh wait, let me call it a portfolio. Um, yeah, I think yeah, let me go ahead and also change the color on this, make it yellow. Okay, so we can see that NVIDIA has the highest beta. JP Morgan has the lowest beta. So yeah, that about wraps it up for this video. I thank you all for watching my video. I'm gonna keep coming out with more and more good content, so stay tuned and peace out.